Cocoon stifling, drying and hot air dryers. Objectives of cocoon drying. The key goal of cocoon drying is to protect cocoon quality, preserve condition of cocoons for reeling and prevent damage caused by long periods of storage. The first hazard is the continued metamorphosis of the pupa. A newly emerged moth will pierce the shell, rendering the cocoon useless for conversion to the raw silk. Exposure to excessive moisture within the cocoon causes putrefaction and molds. Drying kills the pupa and evaporates moisture that would otherwise ruin cocoons. The main objective of cocoon stifling or drying is to kill the pupa without damaging the cocoon shell by using different methods. Mechanism of cocoon drying. Water content will vary according to silkworm type. Rearing seasons and whether a cocoon is produced by a male or female. As the majority of water is contained in the body of the pupa, the extent of drying will depend upon the actual moisture content. When fresh cocoons are placed in the drying machine, water in the cocoon shell evaporates rapidly and heat enters the pupae through the shell. After the pupa is dead, generally 10 minutes water in the pupal's body evaporates very quickly. Cocoon drying continues gradually and when the desired amount of water has evaporated. The speed of drying is reduced relative to the decrease of moisture until drying is completed. A. Drying temperature. The drying temperature impacts the cocoon shell and its resultant raw silk yield. For example, if the temperature exceeds certain limits, sericin degenerates and concurrently efficiency, reliability and raw silk percentage declines. It is advisable to observe the following limits. For hot air drying, 115 plus or minus 5 degrees centigrade is recommended on contact with the cocoon. For steam heat drying, 102 plus or minus 2 degrees centigrade is a preferred guideline. While setting a higher finishing temperature increases drying efficiency. The melting point of sericin declines when the drying rate exceeds 50%. The finishing temperature should be reduced gradually from 60 degrees centigrade in hot air drying and 55 degrees centigrade in steam heat drying. Effect of wind, humidity and velocity. The humidity of drying air has little influence on cocoon quality. However, poor ventilation can cause high temperature and humidity, which will hurt reliability quality. It is advisable to maintain the relative humidity at 4 to 5% at the initial stage of drying and at 16 to 19% at the latest stage to prevent excessive reductions of water in the cocoon shell. Various methods of stifling or drying. In developed countries have advanced techniques of sericulture. Bioltin cocoons are dried using hot air generated by electricity or steam. This modern method is only suitable for bivoltine species. In tropical areas where multivoltine cocoons predominate, the main procedure is steam stifling. The following describes the three methods of cocoon drying in commercial use. 1. Sun drying. No investment is required to kill pupa and dry cocoons in bright sunshine. Clearly, this is only possible in tropical and subtropical zones. Fresh cocoons are spread in thin layers on a moat or planks of wood and exposed to direct sunlight. Depending on the strength of the sun, the process takes 2 to 3 days, though cheap and simple to employ. The main disadvantage is silk fibers' sensitivity to ultraviolet rays, which harm fiber strength and color. Since there are limited facilities for quick marketing of cocoons, Sun drying continues to be utilized in many tropical and subtropical countries. Steam stifling. Generally, in many tropical and subtropical countries, fresh cocoons are heaped into a basket and steamed in small reeling units. In big reeling units with a boiler, the steam chambers are used for stifling. Chamber steaming represents an improvement over baskets as the cocoons are spread in thin layers. Steam works well for multivoltine cocoons which are soft and reel easily without long periods in storage. After steaming, these cocoons may be easily cooked in an open pan, a method commonly used in India. Steam is rapid as pupae are killed within 30 minutes. Immediately after stifling, the cocoons are spread on spacious, well ventilated shelves and left for 3 to 4 days, partially drying prior to reeling. Next, hot air drying. The hot air drying method is very common for biolutin cocoons in sericulturally advanced countries. The hot air dryer essentially comprises 1. Drying chamber in which fresh cocoons are placed preferably in thin layers. Second, a fan to maintain constant and uniform air current throughout the layers along with an efficient ventilator to dry out moisture avoiding condensation inside the chamber, and a heater for heating the air driven by the fan. Precise thermostatic control for regulating the temperature should also be installed in the drying. Degree of drying. Optimum percentage of drying signifies that fresh cocoons have been processed from 37 to 42% to withstand storage over a long period. Excessive drying occurs when percentage exceeds the ideal range. For example, 40% of drying means that 100 grams of fresh cocoons have been dried up to 40 grams. Correct drying enables cocoons to withstand long-term storage of 6 to 12 months without developing mold. When the fingers can crush the pupa, the optimum degree of drying has been achieved. Much skill is needed to derive this ratio empirically. Types of drying machines and methods. The silk industry now utilizes a range of drying machines and attachments suited to available technology plus drying conditions. The following are most popular used: shelf carrier or cabinet type, one band type, multi-band and low temperature air duct type. Shelf carrier or cabinet type dryer. This type performs the drying operation through a chamber which has layers of trays with perforated bottoms. Numerous steam pipes are laid in parallel under the bottom and on opposite walls to heat the inside of the chamber. Fans are fixed on opposite walls in order to produce the parallel air current on each tray of the shelf carrier. Radiated heat and natural air currents then dry the cocoons. Drying method. Initial temperature is 100 degrees centigrade plus or minus 2 degrees centigrade, which is gradually lowered to the finishing temperature of 60 to 50 degrees centigrade. The drying time from fresh cocoons to the required dried state is about 7 hours. Because of its simple structure, this type of dryer can malfunction if temperature control and distribution is not skillfully carried out. Considerable manual labor is needed to spread cocoons on the trays and remove them after completion. The cabinet type of cocoon testing places the fresh cocoons in dryers for drying and is equipped with an aerophane heater and powerful electric fan at the upper section. The electric fan makes the air circulate inside the machine by changing the revolution direction at given intervals for minimizing uneven drying. This style is adequate for the pilot silk reeling plants on research institutes. One band type dryer. This is a one band type continuous system medium sized cocoon drying machine incorporating wire netting conveyors. Cocoons are spread on the wired net conveyor at 300 to 400 mm thick by a cocoon supplying conveyor. The machine consists of 4 to 8 chambers according to the drying capacity with a moving conveyor and equipped with an air blower, heater, air supplying and exhausting dampers and thermocontroller in each chamber. Hot air circulating type dryer. This machine dries cocoons with hot heated outside the machine, which is then blown in. It has three sections, upper, middle and lower, which have different air heating conditions. The multi-step improves drying efficiencies by being able to maintain the drying conditions acceptable by perpetuating a steady circulation of air. The temperature at the commencement of drying is 110 to 115 degrees centigrade, which is then lowered in stages to 100, 90, 80 and 70 degrees centigrade until the final temperature of 60 to 55 degrees centigrade is reached. The duration of drying from fresh cocoon to standard dried condition is 5.5 to 6.0 hours. When the target degree of 39 to 42% drying can be reached. There are various kinds of this type of dryer such as the 6-step, 8-step and 10-step. The 8-step temperature dryer is the most preferred. This type has strong advantages such as even drying achieved by a proper mixing of cocoons and economical heat energy settings for drying. Even though it is expensive and demands much space for installation, this dryer is therefore suitable for the large scale modern silk reeling factory. Low temperature air duct type dryer. This type is often chosen since it can be used as storage room after use. Warm air from the upper part of the air chamber goes through the cocoon storage and comes out of the underfloor after drying. Thick layers of cocoons can cause uneven drying. Therefore, proper filling at reasonable intervals is desired. This method has strong advantages such as fewer installation costs and the dual purpose of drying and storage if continuous supplies of fresh cocoons are obtained during the drying work. Yamato hot air dryer. An old type of hot air conditioning equipment consists of three functional parts: a long rectangular wooden box for keeping the fresh cocoons for drying, an air heating equipment of simple design, and a blower or fan operated by hand or driven by motor. These parts were connected by ducts to obtain continuous airflow from the blower to the exit of the cocoon drying chamber. This equipment was inadequate for the purpose of satisfactory conditioning because it lacked the necessary adjustments for controlling temperature and airflow and also for making the process continuous. In the subsequent models, some of these deficiencies were overcome. One such equipment consists of a tall rectangular chamber of masonry with white cement plastering inside or chamber of pressed metallic plates lined inside with asbestos sheets. Internally, this chamber is subdivided into 5 compartments of equal size on below the other. The first 4 compartments in the descending order are separated from each other by means of sliding wire mesh screens with a handle outside the chamber so that they can be pulled out and pushed back into positions as required. The 4th and the 5th chambers are similarly separated but by a fixed wire mesh screen. The chamber immediately above the lowest chamber is provided with a door on one side to enable unloading of the conditioned cocoons when conditioning is completed. As regards the air heating equipment, it is of simple design. A masonry oven or furnace is built with a metallic cylinder passing through it. This cylinder is provided with a series of baffles internally to slow down the passage of air through it, so as to facilitate proper heating of the air blown through it. One end of the cylinder leads to the lowest compartment of the cocoon chamber, and the other end is connected to the blower. The blower is massively constructed and generally provided with an electric motor. Air current through the air heater and cocoon chamber is regulated by the speed of the blower fan, providing a cone or step pulley for the blower. If the cocoon conditioning plant is required for conditioning very large quantities of cocoons at a time, a battery or series of such independent vertical chambers are provided, making suitable arrangements for hot air supply by adjustments in dimensions of the air heater and in the speed of blower. Operation: fresh cocoons are filled to about 2/3 capacity in the topmost chamber. After about 3 hours of exposure of these cocoons to hot air 50 degrees centigrade supplied from the air heater, the wire mesh sliding door is pulled out and the cocoons dropped to the lower chamber where the temperature is 70 degrees centigrade. After 3 hours exposure, the cocoons are again dropped into third chamber where the temperature is 75 to 80 degrees centigrade. Again, after 3 hours, the cocoons are dropped into the fourth chamber where the temperature is between 80 to 90 degrees centigrade. In this fourth chamber, the drying is completed in 3 hours. The dried cocoons are drawn out the fourth chamber by opening the side provided of the purpose. Thus, the fresh cocoons loaded into the top chamber pass through the 3 chambers at different temperatures at regular intervals to be finally treated at maximum heat in the fourth and final chamber before discharging. This process, therefore, requires a total of 12 hours for complete desiccation. The process of cocoon conditioning is kept continuous by regular feeding of fresh cocoons in the topmost chamber. The cocoons at the time of withdrawal from the conditioning chamber after full drying are at a temperature of 90 degrees centigrade, and therefore the cocoons requires to be aired and cooled before storing the bags. Other methods: many methods other than steam and hot air have also been tried for killing pupae. They are briefly indicated below. 1. Use of infrared rays. The quality of silk is said to be well preserved if the cocoons are not exposed to high and prolonged temperature, which renders sericin hard and consequently affect the reliability. Initially, the cocoons are dried partially to reach 60% dry weight, and later by exposure to lower temperature, it is allowed to reach the optimum drying ratio of 40% of green weight. However, the utility of this method is yet to be established on account of the high cost involved and marginal or negligible improvement in the reliability of the cocoons. Second, cold air killing. In this method, pupae are stifled completely by the use of cold air at -10 degrees centigrade for 6 hours and at -20 degrees centigrade for 4 hours. However, maintenance of temperatures below freezing point requires heavy investment in installation of cold storage machinery as compared to the utilization of high temperature. Further, the cold storage plant will have to remain idle for long spells, which would greatly add to the cost of stifling, and this method does not confirm any extra benefit in good reeling. Third one, radio wave killing. If a high frequency impulse of 3 to 10 meter wavelength is passed through the cocoon, the pupa is killed within 2 to 5 minutes. In this method, the heat impinges quickly on the body of the pupa on account of its higher moisture content, and consequently there is immediate absorption increases beyond this point of some time. Compared to the above stifling methods, this achieves stifling at a lower temperature and in a shorter time. Further, there is a very little effect of the temperature on the cocoon shell fiber. However, this method is said to be applied on a commercial case. Fourth, poisonous gases. Various kinds of gases have been tried, such as sulfur dioxide, sulfurated hydrogen, and liquids such as carbon disulfide, chloropicrin, etc. Sulfur dioxide had to be abandoned because it damaged the silk. Carbon disulfide and chloropicrin are unsuitable because of their poisonous effects on inflammable nature. Effects of drying conditions on reeling units. The initial drying temperature has the largest effect on the cocoon shell. When the temperature exceeds the highest limits, sericin is sharply degenerated, leading to a decrease in raw silk percentage. In the case of steam heat radiation drying, if the temperature is raised too high, it is liable to cause uneven drying as radiated heat degenerates the quality of the cocoon, bringing about bad results. If the initial temperature for cocoon drying is lowered too much, it is opted to deteriorate the neatness and cleanness results of the raw silk quality. Incomplete drying may cause uneven cooking results and consequently lower the raw silk quality in relation to cleanness and neatness. Cocoon storage. For dried cocoon storage, the best condition will keep the raw material for longer period without any damage from molds and pests. In building the cocoon storage room, the following should be considered. Air space for ventilation must be provided at the bottom of the storage room to prevent moisture coming up from underground. The cocoon stores should preferably be built with double walls. If there is no double wall, every endeavor should be made to have the walls as thick as possible. Windows should be small and fixed at a high level and provided with an exhaust fan to enable moisture accumulating in the room to be drawn out. The storing room should be lined with an iron sheet. The window should be covered with a wire net of about 1.5 millimeter mesh. The entire interior of the storeroom should be lined with wood paneling including all walls, ceiling and floor. Cloth or polyethylene bags are recommended as containers for dried cocoon storage. Cocoons weighing 200 liters are generally put in a bag. Shells should be provided in 3 to 4 ties and cocoon bags should be stored there. Bags should not be piled together. Alternatively, the warehouse should be partitioned into many small rooms in which dried cocoons can be kept loosely. A cocoon storage bin, honeycomb tub type, is recommended to reduce the fungus damage caused to dry cocoons during storage, especially during humid seasons. If humidity exceeds 70%, action should be taken to reduce humidity, such as scattering calcium chloride or silica gel on the floor. Also, a heater can be used. Precaution should be taken to prevent fires. After a long period of rain, if it is found that pupa on testing has a moisture content of 15% or over, it will be necessary for the cocoons to be taken out on a clear day and spread out for drying in the shade. If there is danger of fungal damages, it will be advisable to re-dry the cocoons at 60 degrees centigrade for 2 hours.